First derivative test with rectilinear motion. Our objective is to use the derivative to solve problems about the motion of an object. First derivative test with rectilinear motion. This is motion along a horizontal line like the x-axis. Let the distance s of an object from the origin at time t be given by the function s equals f of t. Then the velocity v of the object is the derivative of the position, ds dt, or sometimes we see it as s prime of t, and because we wrote s as f of t, we could also write this as f prime of t. Now remember how the derivative can tell us if a function is increasing or decreasing? Therefore, the velocity of an object can tell us if the position is increasing or decreasing. If the velocity, or s prime ds dt, the derivative of position, is greater than 0, positive, the distance s from the origin is increasing with time t, and the object moves to the right. If the velocity, the derivative of position, is less than 0, negative, the distance s from the origin is decreasing with time t, and the object moves to the left. Remember, rectilinear motion is motion along a horizontal line, so that's only moving right and left. If the velocity, the derivative of position, equals 0, the object is at rest. Examples. An object moves along a horizontal line so that its distance s from the origin is at time t greater than or equal to 0 in seconds, is given by s equals t cubed minus 9t squared plus 15t plus 3. A. Determine the time intervals during which the object is moving to the right and the time intervals during which the object is moving to the left. So we think of this as the object is increasing its position, call the position S, and decreasing its position, decreasing position or decreasing S. Well, if we want to know where a function is increasing, we want to know about its derivative. So that's going to be where the derivative, which is the velocity, is greater than 0. And where a function is decreasing, if it's a position function, that's going to be where the velocity is less than 0. So we need to start by finding the velocity and figuring out where it equals 0, or rather, figuring out the critical numbers of the position function s. So we take the derivative to give us the velocity. V is the derivative of the position, which is 3t squared minus 18t plus 15. We'll set that equal to 0 to find our critical numbers, or where the velocity is 0, and we can factor out and divide by a 3. If we divide both sides by 3, we get t squared minus 6t plus 5 equals 0, and then we can factor what's left over to t minus 5 times t minus 1 equals 0, and that yields the values 5 and 1 for t. Now we set up our intervals. And we want the sign of v, the derivative of the position. Make sure that we put these in order, 1 and 5. And normally we would be starting at negative infinity. But remember that this is time, and it doesn't make sense for time to be negative, and they told us that time has to be greater than or equal to 0. So 0 is going to be the beginning of our interval. We'll mark it here, and we'll put it in our interval. First interval going 0 to 1, next interval 1 to 5, and there's no limit on the time restriction greater than 0, so the last interval 5 to infinity. Now we figure out the sign of v by using the factored form of the derivative. Pick something on 0 to 1, like 1/2. Plug it in, that's a negative times a negative, and of course 3 is positive, so that yields a positive value. From 1 to 5, like 2, that's a positive times a negative, times a positive, so that's a negative. And from 5 to infinity, like 10, and that's a positive times a positive times a positive yields a positive. So we see the sign of V, and we can use that to interpret what S, the position, is doing. If its derivative is positive, that means the position of S is increasing, or rather moving to the right, because it's rectilinear motion, motion along a horizontal line. Then V is negative, so the position is decreasing, or rather the object is moving left, and then the derivative being positive means the position is increasing, or the object is moving to the right. So now we can make our conclusions. The object is moving right on the intervals 0 to 1 and 5 to infinity, and we'll justify by talking about our velocity, because the velocity is greater than 0. The object moves left on the interval 1 to 5, and again we'll justify with the velocity being negative. B, when does the object reverse direction? So we simply look back to our sign chart and see changing position from moving right to moving left. That happens at t equals 1. And then changing moving left to moving right. That happens at t equals 5. C, draw a figure that illustrates the motion of the object. So because this object is only moving right and left, we're going to show a horizontal line that is labeled as S for the position of the object. Now we want to note some positions where it is at some important points in time, like the time at the beginning. So what is the position at time 0? S of 0, if we go back to the original function and plug in 0, we'll get 3. Other important times are when it changes directions, like at t equals 1. So we'll plug in 1 into our original function. That gives us 10. And it changes directions again at 5. So we'll plug in 5, S of 5. So that's into our original function, and that yields negative 22. So we want to plot these position values on our position line. So we've got at time 0 the position 3, and just like a number line, 10 will be to the right of 3, and negative 22 then would be way down here to the left of 3. So we mark with a point and label that this point is at t equals 0 times 0. Now which direction does it move first? It moves to the right. So we show it going to the right, and when does it turn around is at t equals 1, which is at position 10. So it gets to 10 and then it turns around to go left. So we'll mark that at position 10, which is at t equals 1, that it turns around and starts going the other direction. It keeps going to the left until it gets to time 5, and at time 5 it's at position negative 22. So keep going all the way to negative 22 before we turn around and go to the right again. And this is at time 5 at that position, and then it keeps moving to the right forevermore. So this is a way that we can illustrate the motion of the object. D, when is the velocity of the object increasing and when is it decreasing? So remember that a function is increasing when the derivative of that function is positive, and the function is decreasing when the derivative of that function is negative. So if the function is velocity, it's when velocity is increasing when v prime is positive and decreasing when v prime is negative. Well, what does v prime give us? That's right, the acceleration. So when the acceleration is positive, velocity is increasing, and when acceleration is negative, the velocity is decreasing. So let's start by finding the acceleration. Acceleration is the derivative of velocity. So looking back to our velocity function, 3t squared minus 18t plus 15, we get 6t minus 18. Now to figure out where acceleration is going to be positive and negative, we start by finding our critical numbers, which is where the acceleration equals 0. That's going to be at t equals 3. So again, we do our first derivative test and make our sine line with our intervals, and then our sine of v prime, or acceleration. Again, because this is time, we can't go lower than 0. So 0 is our starting time, and then we only have one t value, that's at 3. So two intervals, 0 to 3, and then 3 to infinity. We'll pick a test value on the first interval, such as 1, and we'll look to our derivative. If I plug in 1, I get a negative. Something on the interval 3 to infinity, like 10, I plug in 10, I get a positive. So we think about what this means for velocity. If v prime is positive, v is decreasing. If v prime is, I said positive, negative, v is decreasing. If v prime is positive, v is increasing. So we can say the velocity increases on the interval 3 to infinity because v prime is greater than 0, or because acceleration is greater than 0. Either justification would work just fine. Similarly, we can say that our velocity is decreasing on the interval 0 to 3 because v prime is less than 0, or a is less than 0. Either way works just fine. E. Draw a figure that illustrates the velocity of the object. So similar to what we did for the illustration of the motion of the object or the position, we're going to make a horizontal line, but this time label it v for velocity. Again, we want to find some values, such as what's the velocity at time 0. So going back to our velocity function, which was up here at a, here's our velocity. Plugging in 0 gives us 15 there. V of 0 equals 15. Then we want to plug in that other critical number where the velocity changed from decreasing to increasing, and that's 3, and plugging it into the velocity function yields negative 12. It's also useful to note that the velocity equals 0 at t equals 1 and 5, which we got from part A as well. So let's mark 15, that first value, on our number line, and negative 12, that's our lowest value, on our number line. And then we can plot first at time 0 that we had a velocity of 15, so we'll put a point there and say that that's at t equals 0. First, our velocity is decreasing, so it's going that way, and it goes that way all the way to negative 12, where the velocity changes to be increasing. This is where it turns from decreasing velocity to increasing, and that's at time t equals 3. Now we can also mark that the velocity equals 0 at time 1 and 5. So 0 is going to be approximately right here on our number line. The velocity is 0, and so that's going to be at two places. The first place we get to is at time 1, and the second time v reaches 0 is at time 5, and then the velocity just continues to increase. Part F. When is the object speeding up, which means speed is increasing, and when is it slowing down, which means speed is decreasing? Again, I'm going to emphasize that speeding up means speed is increasing, and slowing down means speed is decreasing. It's important to note that speed is the absolute value of the velocity. Remember, when a function is increasing, the derivative of that function, I'm going to write that as d dt of the absolute value of v, is positive. When a function is decreasing, that's when its derivative, so the derivative of the speed, d dt of the absolute value of the velocity, is less than 0. Another way to think of this is if we're saying speed is increasing and speed is the absolute value of velocity, and the absolute value of numbers makes them positive, that would mean the numbers get larger or move away from 0. So we're going to describe speed increasing as the velocity values move away from 0. Because velocity can be positive or negative, it's important that we don't just say get bigger, but we say, or that rather we don't say get bigger, but we say moves away from 0. If we took the absolute value of the values, they would be getting more positive, but we want to think about it as the velocity moves away from 0. If speed is decreasing, the way we can think about that is that the velocity moves closer to 0. So looking at our illustration of the velocity of the object, on what intervals is the velocity moving away from 0? Well, notice at first the velocity is moving closer to 0 until time 1. Then between time 1 and time 3, it's moving away from 0. So speed is increasing on the interval from 1 to 3. Turning around, the velocity values are getting closer to 0. But then after 5, the velocity values start to move away from 0 again. So again, from 5 to infinity, speed is increasing. When is the object slowing down? When is speed decreasing? Well, we need to look at when does velocity move closer to 0. Starting at time 0, the velocity values are getting closer to 0 until time 1. So that interval is 0 to 1. But then the velocity values move away from 0. But at 3, that velocity changes and those values begin to get closer to 0. So then again, from 3 to 5. Thanks for watching.